Welcome to Tech Teach.
The full form of RAID architecture is redundant array of independent disks or drive, basically. So redundant array of independent disks, as the name suggests, it is an array of different disks. Disks, what type of disk? The disk is like the hard drives. So different hard drives will be there. So suppose you are having a memory or you are having a data, you want to store it into a hard drive, and suppose that hard drive fails, then the complete data will be lost. Cloud is like we are having the clouds. So in the cloud also, like they store the data, and they not only store the data, they duplicate the data to other disks also. So they have different copies of the data, so that if even one disk fails, some other disks are having the data, so you can recover your data. So that is the basic use of RAID architectures here. So RAID is redundant array of independent disks that are basically used to increase the efficiency in terms of like fault tolerance. It can have the capability of handling errors. Even if some errors are there into the hard drives or drives, they can retain the data. It increases the speed also, and redundancy. So redundancy in the sense there will be some extra hard drives basically used to store the data. Okay, so it will be like it will be storing. So what are the different capabilities of RAID is? It basically uses different, instead of storing the data in one disk, it will be storing into two different disks. Same drive will be stored into disk 1 and disk 2. So it is an storing the data with respect to redundancy, means same data is used stored again and again. So that is are stored in two different drives. So that is similar to like it is having a redundancy. The advantage of having multiple disks. What is the advantage of having multiple disks? So your separate input output requests can handle in parallel. So how it will be increasing the speed? If the data is stored, same data is stored into two drives, parallel processing can be done by having the same data into multiple disks, as long as the data required reside on separate disks. So based on the requirement, the data can be retained in multiple disks, or based on the requirement, we can remove it also. But in RAID, basically, it uses multiple disks to store the data. A single input output request can be executed in parallel if the block of data to be accessed is distributed across the multiple disks. Here, a single input output instruction can be executed, a request can be executed parallelly if the data is available into multiple disks. So the few part of the instruction or the request can be accessing the data from disk 1, and other can have that accessing the data from disk 2. So the parallel processing can be possible with the help of multiple disks. So here are different types of RAID architecture basically. So here RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5, RAID 6, RAID 1 and 0. So combination of 1 and 0, that is RAID 1, 0. So different types of RAID architecture is there. So we'll see what are these types are there, how they are basically facilitating the multiple disk system, and how they are basically creating an error-free or fault-tolerant system, and also it is increasing the speed. So one by one, we will be basically going to see. So three common characteristics of different RAID architectures are: operating system will be looking out the complete RAID system as a single drive. It will not be differentiating like the different disks are combined together, made up or combined together to create a RAID architecture. It will be considering all as single system or single memory drive. Data are distributed across the physical drives of an array in a scheme known as stripping. So data will be uh, distributed across different disks in the stripping manner. So what is the meaning of stripping? We will be just letting you know. Redundant disk capacity is used to store parity information. So redundant disk in capacity means if multiple disks are there, some spaces are available in a particular disk. So some parity information will be used along with the data to basically uh, remove the errors. Sometimes suppose data is stored and it is having some error. To remove that error, some parity bits are used to remove the errors. So that parity bits, for storing the parity bits, separate or available or redundant spaces of the disks are basically used to store the parity information, which guarantees data recoverability in case of disk failure. If the disk is failed, that parity information will be able to helpful in recovering the data. So basically, this error detection and correction is basically done with the help of parity information. So we'll see the first one, that is the red 0. So what is the red 0? So it supports data stripping. So what is the meaning of data stripping? So first of all, it will be having multiple disks. Multiple disks will be there. Suppose whatever the data. So suppose this is the data. So it will be breaking this data into multiple parts, and one part will be stored into one disk. Another part will be stored in another disk. Then next part will be stored into another disk, and another part will be stored into another disk. So likewise, this is called basically the data stripping. So it supports data stripping. Okay, and multiple disks are basically used to write the data. It's not like the complete data will be stored into a single uh, disk. It will be using multiple disks to store us data into smaller parts. So complete data is there. There will be some part of the data will be stored into disk 1, some part will be stored into disk 2. Likewise, it will be stored. So strip 0, strip 1. So complete data will be break into smaller parts, and smaller parts will be stored into different disks. So this is called the RAID 0. And here it is called non-redundant. So what is the meaning of non-redundant? Because here non-redundant in the sense, in this case, if suppose data disk 1 fails, it is failed. If this disk is failed, then this complete data will be lost. It can't be recovered. So that's why it is non-redundant. There is no capability to recover the data. So it is having no fault tolerance. So this red disk is similar to having multiple disks, but this is not having a fault tolerance system. So there is no fault tolerance system into the RAID 0. What is the advantage of it? So it supports pipelining. So pipelining is supported. So if the data is there, it is stored into multiple disks. So pipelining can be possible. So it increases the speed, it increases the performance, and it increases the throughput by supporting the pipelining. But it is not having the fault tolerance. So to remove this fault tolerance of no fault tolerance was there into this RAID 1 RAID 0. So there comes RAID 1 now. So to remove that, there is a concept of mirroring. So mirroring is basically done in RAID 1. So RAID 1, second one is the RAID 1. It supports the mirroring. Means whatever is the data. So one data is there, strip 0. If the complete data is there, it is divided into multiple strips. So one strip will be stored here, one strip will be here, one strip will be here, 4. So 0, 1, 2, 3. The same data will be stored into some other disks also. So these are called the mirror disks or mirror drives, where one copy of the same data will be stored into the mirror drive. So mirroring of the data will be done. Means same data will be copied and put into some other disk. So what is the advantage of it? Now it becomes fault tolerant. How? If suppose the disk 1 fails, then also the data will be available into the mirror disk. So it is a fault tolerant system. It also supports pipelining. It increases the performance. It increases the speed. But what is the disadvantage of it? So disadvantage of it is large number of disks are required. So extra for mirroring we are using. So large number of disks will be required. This is the disadvantage of RAID 1. Next is the RAID 2. So RAID 2 is having redundancy through Hamming code. So this RAID 1 can be called like it is having redundancy. It has redundancy. Redundancy means it is having the capability to restore the data. RAID 2 is called redundancy with Hamming code. So here, along with the data, if the bit is there, means data means here the data is not in the form of strips, the data will be in the form of bits. So one bit will be stored in one drive, another bit, another bit, another bit. Along with this, there is few disks that will be storing the Hamming code, or we can call it like check bits. Check bits are used. So this is the data. If 4-bit data is there, so for 4-bit data, 3-bit check bits are required. If 8-bit data is there, then 4-bit check bits are required. So there will be few disks for data, and there will be few disks for the redundant bits, for storing the redundant bits. Redundant disks basically that is used for storing the redundant bits. So in RAID 2, the bitwise stripping is basically done. Here in RAID 0 and RAID 1, stripping is done in group of bits. So suppose this is the data. So multiple datas are there. Suppose whatever is the data. So here the stripping will be done in terms of group of bits. Okay. So that is the stripping in RAID 0 and RAID 1. But in RAID 2, the stripping will be done in the form of bit. So bitwise stripping is done here. And here it will be having extra redundant redundant disks are there that will be used to uh, store the check bits or redundant bits that will be helpful in recovering the data if a particular disk fails. If suppose this disk fails, it will be able to recover the data with the help of the having codes or the check bits. Next one is the fourth one, that is RAID 3. So RAID 3 is called bit interleaved parity. So here also in case of Hamming codes, here the more number of disks were required to store the redundant bits. So to reduce that, there will be bitwise stripping. So bitwise stripping will be there here also. And here it will be using the parity bit. It will not be using the check bits. Check bits with respect to Hamming codes have more number of bits, but the same error detection can be done by using parity bit that requires only one disk or only one bit to store. So it has the parity disk. So in case of disadvantage here, more number of more disks are required. But here, less number of disk will be required. This is called the bit interleaved parity. Next one is the fifth one, that is RAID 4. So this is called the block level parity. So here the parity disk will be there, parity disk, but it will be with respect to block. It is not the bitwise. It is the block wise. So group of bits will be saved into one disk, and then the parity bit will be stored. So it is a 3-bit block is there or 4-bit block is there. So with respect that the parity will be stored into 3 or 4-bit into one disk. Here the bitwise parity were stored, but here in RAID 4 the block wise will be used. So further it will be reducing the requirement of the size also, disks also. Some advantage and disadvantage is there. So here there is an issue of bottleneck. So bottleneck in the sense, sometimes the sometimes the particular suppose data is being accessed or required, okay, and or suppose a data is being required, and at the same time the parity is being asked, and it is available into all the parities are available into the single disk only or single parity disk only. So suppose one instruction is using the parity from here, so other one can't use it because it is being used already. So there is a bottleneck. So bottleneck in the sense, if a particular resource is being already used, so so that others can't use it. So there is a bottleneck problem because most of the parities are available into single disk. So there is a bottleneck problem into RAID 4. So to remove that, there is a sixth one, that is the RAID 5. So RAID 5 is it will not be putting the uh, parity bits into a single parity disk. It will be having the instead of putting in single, the parity bits will be put into multiple disks. It will not be having the parity bits into a single disk. Now, if the data is required, if the parity is required, parity can multiple parities are saved into multiple disks. So there is the removal of the bottleneck. So it basically removes the RAID 5 basically removes the bottleneck problem into the disk RAID 4. So it is distributed parity bit is basically used here. Next one is the RAID 6. It is the dual parity drive. So dual parity drive means there will be dual parities will be used. So dual parities P and Q is there. So few part will be used into one disk, another will be used here. So likewise, there will be dual redundancy. Okay, so dual redundancy will be there, dual parities redundancies will be there into RAID 6. The next one is the RAID 10. So it is having RAID 10, that is combination of RAID 1 and 0. So what is the advantage of first and 0 and 1? So there will be stripping as well as mirroring. That is combined together. This is called nested stripping. So that combination is the RAID 10. Into RAID 10, it will be having the stripping as well as the mirroring. That is what this RAID 10 is there. And here is the summary of all the RAID architectures. So you can just go through it. What is the advantage and disadvantage? How many disks are required? What is the label? Okay, what criteria is there? Based on that, it is basically defined. So here N is the number of disks and M proportional to N log N. So M here is there. This M value is proportional to log N. Okay, so total number of disks, how many disks are required basically, what is the data availability, what is large input output data transfer capacity is there, whether there is or not. A small input output request rate is there, what if the what is the small input output request is, rate is there, or if how many data transfer can be there, capabilities are there. So based on that, it is basically provided different criteria of different RAID architectures.